Until recently, scientists, along with the whole world, believed that interstellar space was silent. But the latest data that Voyager 1 transmitted back to Earth disproved that. What's that sound? Where did it come from in lifeless space? And these are not the only weird signals we got from the Voyager mission. Earlier, Voyager 2 sent back data that transformed our view of interstellar space density. In 2018, Voyager 2 entered interstellar space and immediately discovered something strange. We used to think that space was a vacuum, almost devoid of matter. But it's not strictly true. Solar wind density is from 3 to 10 particles per cubic centimeter. And at the boundary of the solar system, this value goes down to 0.002 of an electron per cubic centimeter. But in 2019, at a distance of 18.5 billion kilometers from the Sun, Voyager 2 reported an increase in the density of matter to 0.012 of an electron per cubic centimeter. Scientists still don't know the exact reason for why this is happening. But the more data we get from Voyager, the more we'll be able to study the interstellar wind. And for that, these are the vibrations of plasma, the most common substance in space. For example, stars are composed of it. The vibrations occur when solar plasma emissions come across the plasma of interstellar space. So far, there's nothing unusual about this, but in 2017, Voyager 1 picked up a faint but constant signal at a frequency of about 3 kilohertz. This continuous signal lasted for about 3 years. During this period, Voyager 1 traveled more than 1,600,000,000 kilometers, but the signal didn't change. The Voyagers have been collecting data in outer space for 44 years now. But what awaits them in the future? In 40,000 years, Voyager 1 will fly past, at a distance of 1.5 light years, the Gliese 445 star in the Camelopardalis constellation, and will then continue on its voyage through the Milky Way. In 300 years, Voyager 2 will reach the Oort cloud, a spherical layer of icy objects that surrounds our solar system. In 40,000 years, Voyager 2 will pass at a distance of 1.7 light years from the Ross 248 star in the Andromeda constellation. And in 296,000 years, Voyager 2 will fly past Sirius in the Canis Major constellation. But we'll most likely never know about any of this. When the spacecraft run out of fuel, they'll continue moving on in their respective journeys, but they won't be able to adjust their antennas to transmit signals back to the Earth. In fact, Voyager 2 will lose contact with us in the year 2034, and Voyager 1 will only be able to receive and send signals until the year 20.